Hey guys, this is my alkyne synthesis video. So if you want one-step and multi-step synthesis on alkyne reactions, which we'll subsequently focus in on, as well as alkene reactions, because all these reactions go together, and you'll see that with these practice problems. So a little bit of a review on alkyne synthesis. These are most of the equations that you'll need. This does seem very scary to look at, but I promise if you do enough practice problems, which hopefully this video will be helpful for you, these will all come into fruition and into memory. So let's get started. So this question asks to propose an effective synthesis for this following transformation. So we want all the reagents in order to make this happen. So let's start with this triple bond. And first step that you guys should signal here is that, what does this look like? That kind of looks like a cis kind of structure, right? Just without that double bond. So that's something to look for. Let's count our carbons from our starting material and our product. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So we need to add some carbons before anything else. So let's do that. And to add carbons, there's one way you can do it, is by doing NaNH2, and we need 2 more carbons on our other side of our triple bond. So let's do that. Let's add an ethyl group, and we always put iodine, some kind of halogen, to take that positive charge away, you could say. So we have this going on now, and we have 6 carbons, so that's very good. And we have 1, 2, 3, so our cis should show up between our 3rd and 4th carbon, and that's where this triple bond is. So we have a good start. And what I mean by that cis is that we want a reactant or reagent that can do that, right? Because that gets us in some good territory. And there's one reagent that actually does do that, where again, this is the cis thing, because these are both going down, so that's the cis isomer, you could say. We can use H2 and Linyard's catalyst. That can get that transformation done. And then our last step here is adding those bromines. So before I add the reagent, I'll show the final product. So what can get this done? And obviously this is plus enantiomer, which means that you just switch around these wedges and dashes. So what reagent can we use? This is going back to the alkene chapter, because we're dealing with an alkene. This is just simple Br2. That can make that happen. So that is our synthesis, right? It's not too hard. Identify how many carbons there are in the product rather than the reactant. And use those reagents that you guys have memorized or used and go through the synthesis. All right, our second one is this one. Let's again count our carbons, because that's very important in this alkyne chapter. So it looks like we have 1 more carbon in our product than we do in our reactant. So the first step that I'll do in our synthesis is add 1. So NaNH2, CH3I. That gives us a methyl group on top. So now we have the appropriate amount of carbons. Now what can we do here? How do we go from that alkyne to the alkene? And this is what? Is this a cis or trans? This looks like a trans alkene. And we can use NaNH3 liquid to do that transformation. Let me count my carbons again, just to make sure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that is our synthesis for this one. Okay. Moving on, I have 2 questions here. So let's look at part C first. Let me rewrite it here. We're going from a looks like an alkyne to an alcohol group. Are we adding any carbons right away? Let's see, we have 1, 2, 3, 4, 1, 2, 3, 4. So we're not adding any carbons, so we don't need to worry about using any of those NaNH2 we're just simply doing this right here. So how can you get to that alcohol group? Let's think of retrosynthesis first. So what is a starting material we could use to get to that sort of product? What do you guys think? I would say that we could use something that involves a double bond like this. I would say that is a possible synthesis strategy that you could use. And we would probably, what reagent would we need to get on a more substituted carbon? Because this, again, is secondary, this is primary. What reagent would you have to use to get to that? You could use H3O+. That's acid catalyzed hydration. So that's that step. Now we just have to worry about how to get to that alkene from that alkyne. We can use the same reagent that we just used, that NaNH3 liquid, to reduce that alkyne into alkene. So that's the synthesis there. Okay. All right, now we have E, which is going from a double bond into a aldehyde. Let's count our carbons. We have 1, 2, 3, 4 in our starting material, and we have 1, 2, 3, 4 in our product. So one important thing to note here is that we didn't learn any reactions in our alkene chapter that can go to a aldehyde, but we did learn a reaction in our alkane. The one with the triple bonds is what I'm getting tongue twisted here. We do know how to go from triple bond to aldehyde, and what an aldehyde is this type of formation. So what I'm trying to say is that we have to go first from this double bond into a triple bond. So we have to think about a way that we can keep the same amount of carbons. We have 1, 2, 3, 4. We have to think about a reagent to go to this first, and then we can think about our a reagent to then go to this final product. So what can do that? Well, we need a first step in between these. This is just building our materials. So we know these steps have to go together. What reagent can we use for this one? I'll have to look back because I'm forgetting myself. So an aldehyde, let's see right here. This is what I thought it was, but I just want to make sure. R2BH, H2O2, NaOH. R2BH, H2O2, NaOH. So we already have that done. We just have to figure out what this middle step is. How do we get there? So my thought process is there's one way that we know how to get a triple bond, and that is by reducing your halogens into that triple bond. So we could use a product, and this is a chiral center, so I'll add a wedge or dash to that. So we can use Br2 at the start to get those two bromines over that double bond, and then we can use excess NaNH2 and H2O. And I'll try to write that neater. Let me erase that and try again. Oops, Br2. Let's pull this over a little bit. So we have excess NaNH2 and we have H2O. That's how you can get those two halogens away, and in place of that get a triple bond, and that triple bond we know has a reagent that we can get that triple bond to that aldehyde. So that's the synthesis there. Let's look at this next one. This is looks like a pretty simple one, right? We're going from a alkene, alkyne, I'm sorry, to an alkane. So let's count our carbons before anything. We have 3 carbons at the start. We have 5 carbons at the end. So we need to add looks like 2 more carbons, so we know how to do that, right? We can just use NaNH2, and we need 2 carbons, so let's do ETI, so ethyl and iodine. So that'll get something like this, where we're adding 2 more carbons to our mixture. And then there's one reagent that you guys have learned to do this reaction. And we learned it in the alkene chapter and the alkyne chapter. So hopefully you guys remember this. It's H2PT. You can also use PD. It's the same thing. But H2PT can reduce that triple bond into just an alkane. So let me count my carbons again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and we're good. So we did that problem. All right, let's try to figure out what the products are if we're given the reagents. So if we're given a triple bond, and our first reagent is to add an ethyl group, so NaNH2 and ETI. So we're adding an ethyl group. And our second reagent is this HgSO4, H2SO4, H2O. What is that reagent? I'll give you guys a few seconds to think about it. That is a reagent to give us a ketone. So what is a ketone? It's a structure like this, and those R's can mean anything. So that's a ketone, and we just have to make sure we count our carbons for this. So we have 4 carbons at the start. We should end up with 4 carbons at the end and a ketone over our third carbon. 1, 2, 3, 4. So that is this, I'll write the third step, I guess. HgSO4, H2SO4, H2O. That is the product. So your final answer should look something like this. And again, hopefully you guys are pausing throughout this video to try these out yourself and looking for the correct answer. So I believe this is the last question here. So again, pause it if you need more time. We're looking for the product of this. So we have 3 steps here to go together. What is the product for this one? All right, so let's rewrite this. We have 2 BRs up here. And our first step is excess NaNH2. That's kind of sloppy. Let me rewrite it. Excess NaNH2. And then we have ethyl chlorine. So I'll just write excess NaNH2 to start. It really should have an H2O beside it, because that would make a little bit more sense. But let's just use that to start. What does that do? That reduces your 2 halogens into a triple bond. So we just have to count our carbons. We have 1, 2, 3 carbons out of here. So we should have 1, let's see, 2, 3 to get that triple bond. And there you go. Our second step is to add that ethyl group to the end of that triple bond. So let's do that. So we have that, and then it has us reduce that triple bond into a double bond by using H2 Linier's catalyst. So that again is the cis reduction agent. So we just have to count our carbons again. We have 1 coming out, 2, 3, 4. So 1, 2, 3, 4. It should go like this more. That shows that both of these groups are going down as a cis type of deal right there. So let me just count them again. 1, 2, 3, 4. We have the correct amount of carbon. So your answer for this up here should look something like this. Okay. So there's the answer there. Hopefully this video helped. Obviously there's a lot of steps that go along to this, and when you start to put all these things together with substitution and elimination and stuff like that, it can be kind of complicated. But if you have a good understanding and good memorization of all these reagents, you guys should all be good. So I'll see you guys in the next one.